Welcome and thank you for joining. Let's take a look at an application of higher order derivatives, and more specifically, we'll look into the connection that exists between the position function and its first and second derivative, which respectively represent velocity, that's the first derivative of position, and acceleration, which is the second derivative of position. Let's read the question first. The position of a cougar chasing its prey is given by this position function. It's a polynomial. Time is measured in seconds, and s, or the position, is measured in meters. We need to find the velocity, so the first derivative of position, and acceleration, that's the second derivative of position, at any time t. And then we have to discuss when the cougar is moving towards the origin. When we say the origin, we mean the point of reference or the initial point. And when it is moving away, then we have to determine when it's speeding up and slowing down. And at the end, we can graph the position, velocity, and acceleration for the first 4 seconds. So we're going to start off by writing the position equation first. And st equals t cubed minus 6t squared plus 9t. Now remember that in order to determine whether an object is moving away or towards the initial point or the origin or the point of reference, we need to discuss the sign of the product st times vt. So in order to determine the sign of this product, we need to know what the sign of each function will be in specific intervals. And the best way to study the sign of a function is by first factoring it. So we'll start off by factoring the position function. As you can see here, we have a common factor of t. So we'll take that out. And the rest will be t squared minus 6t plus 9. So continue factoring some more. As you can see here, we have a perfect square trinomial. So the factored form of the position function would be t times t minus 3 times t minus 3. Now remember, to study the sign of any function, we need to look into the key values or critical points or the zeros of the function. Now the reason why we want to look into zeros is because the zeros will determine where the positives are separated from the negatives. So for any quantity to go from positive to negative, and that's what we're interested in knowing here. So when position is positive or negative, it has to pass through its zero. So the zeros of this function are found by making each factor equal to 0. So we're going to say that the key values are at t equals 0, or whenever t minus 3 equals 0. There is no point in making t minus 3 equal to 0 twice. So, but I'm going to write this down for the purpose of explaining things. Therefore, we're going to say that at t equals 3 and t equals 0, the value of the position function will be equal to 0. Next, we have to discuss or to study the velocity equation. Remember that velocity equation is basically the first derivative of position. So to find velocity, we differentiate the function st, which in this case would be equal to, remember, t to the power 3 is 3t squared. Negative 6t squared has a derivative negative 12t, so 2 multiplied by 6. And derivative of 9t is simply 9. So now we have to study the sign of vt as well, so that we'll be able to see the connection between vt and st. And to study the sign of vt, it means that we need to start off with the zeros of it. So as you can see here, we have a quadratic function. And notice that all the coefficients will have a common factor of 3. So we'll factor the coefficient of 3 out first. And in brackets, we'll have t squared minus 4t plus 3. Continue factoring some more. And we'll have 3t minus 3 times t minus 1. This is very straightforward quadratic polynomial factoring. So the key values for the velocity function are found by making each factor equal to 0. So we're going to say that either t minus 3 equals 0 or t minus 1 equals 0 for this product to become 0. So therefore, we're going to say that Vt would equal 0 if t equals 3 or t equals 1. So far at this point, we have found the key values of velocity and the key values of position. So in order to determine where and at what time intervals the cougar is moving away or towards the origin, then we are going to build a chart to study the sign of both of them, position and velocity. So I'm going to start off by drawing the number line where we will place all the key values. So here we go. We have the 0 first. We have the key value of 1 and 3, which is kind of common for both position and velocity. But obviously we have to write it only once. Then we'll draw a vertical line on the side. And right here, we're going to list all the factors that whose sign we are trying to study. And we have to write them in specific order because being organized matters, especially in problems that require a longer process of solving it. So we're going to start off with a position function. And I'm going to make room for each and every function. So we're going to do position function here, velocity function here. This is where we're going to study the product of the two, and then here we're going to discuss the behavior. Now, from the critical points or key values, we're going to draw perpendiculars down here because that's what will divide the domain into the different intervals. And this is where the signs of position and velocity will keep on changing. So let's list all the factors of position first, which are factors t, t minus 3, t minus 3. And yes, I will be writing t minus 3 twice, and that is because the sign of t minus 3 is different than the sign of t minus 3 times t minus 3. So it is important to list all the possible factors. And another way we could have chosen is to write t minus 3 squared in here, but I find this longer way a little bit more accurate and easier to understand and important to emphasize. So the sign of st would be the sign of the product t minus 3 and t minus 3. Next, we are going to list all the factors of vt. So remember that vt was 3t minus 3, t minus 1. So I'm going to start off with the factor t minus 3, t minus 1, and then I will discuss the sign of vt. And I will definitely include the coefficient, the constant coefficient, or the constant factor that is in front of velocity. Not because in this case matters. When it is positive, we don't really need to include it in the sign of velocity because multiplication by a positive doesn't change the sign of an expression. But sometimes it might happen that we have a negative coefficient in here, and that can change and turn the solution all the way around. So it is important not to omit any of the coefficients. So at the very bottom, we are going to reserve a spot for the sign of the product STVT, which will help us determine whether the object is moving away or towards. And in the very last row, we are going to describe the motion, so if it is moving away or toward, and this decision will be based on the sign STVT. So let's get to work. So all these factors that we have listed will have their zeros either at t equals 0, t equals 1, or t equals 3. And to indicate this, what we're going to do is show where the zeros are. So t equals 0 will be 0 at 0. T minus 3 will have the 0 at 3. T minus 3 again will have the 0 at 3. It is important we indicate those zeros in here because they will guide us as to what sign to assign to every factor in here. And then t minus 3 will have the 0 at 3. Remember that 3 is a 0 for both velocity and position, and at 1. So t minus 1 has a 0 exactly at 1. So the sign of velocity would be determined based on the product 3, on the sign of the product t minus 3, t minus 1 times 3. So for these ones, we don't have to write anything as of yet. We're going to start off by studying the sign of each and every factor. So we're going to go line by line from top to bottom. So we're going to say that since t equals 0 at t equals 0, for any value of t greater than 0, the value of t will be positive. So therefore, we're going to write a plus for every interval. T minus 3, on the other hand, is going to still be negative in here, which means that in the interval from 0 to 1, the first factor t is positive and the other two factors are negatives. So therefore, we're going to say t minus 3. T minus 3 will be positive here. In the interval from 1 to 3, the value of t will be positive because this is all positive numbers, so the t values will be only positive. Now, t minus 3, on the other hand, is still negative. That's because it hasn't reached its 0 yet. And another way to figure this out is pick a number anywhere actually from 0 to 3, substitute it into t minus 3, and check and see what signs you get. So we should get negative. So for example, 1 minus 3 negative, 2 minus 3 negative. Now, a number to the left of 3, 2.9 minus 3 negative. So that's how we determine the signs here. And t minus 3, again, the other t minus 3 will also be negative, which will make this product right here positive. Now, the last interval is from 3 to infinity. So t is always positive. These are all positive numbers. And t minus 3 and t minus 3 are positive, and that will make the entire product positive. Now remember that t minus 3 has passed its 0, which means that the sign will be positive. And another quick way and practical way of determining the sign is pick a number greater than 3, let's say 5, substitute it into the expression. 5 minus 3 equals 2, so that means that's a positive. So the product of the three factors will have to be positive. So as you can see, the sign of the position is positive for any value of t greater than 0. Next, we'll study the sign of velocity. So we'll start off with the sign of t minus 3. So we'll say that t minus 3 will have a negative sign from 0 to 1, because it hasn't passed its 0. That's a 0 for t minus 3. And this is a polynomial first degree with positive leading coefficient, which means it's a line that goes up, which means that it starts low or negative, crosses the 0, and then becomes positive. So therefore, we're going to say they're both negative here, which means that the product will be positive. So we'll look into the interval 1 to 3. So t minus 3 hasn't hit its 0 yet, so it's still negative. And you can pick a number between 1 and 3, let's say number 2. And then we can say that t minus 3 is negative still, but as you notice here, t minus 1 has passed the 0, it's 0 here, which means that the sign of t minus 1 will have to be positive. So we're going to write positive, and as you can see here, the product negative and positive will guarantee a negative in this interval. And lastly, we have the interval from 3 to infinity. So from 3 to infinity, we have t minus 3 that has passed its 0, which means that t minus 3 will now be positive. Now, t minus 1 is already positive, right? And I'm going to say that's a positive. So the product of the two will be positive. Now the fun part. We are studying the sign STVT. So I color coded them so I can see them a little bit better. So ST is in pink and VT is in green. So to find the product STVT, then, and remember, we're not finding the value of the product, we're just studying the sign of the product. All we have to do is look into the sign of each function. So we're going to say that ST is positive and VT is positive. How do we know? Because from 0 to 1, here is ST, here is VT. You multiply them, guess what? You get a positive. Now, in the interval between 1 and 3 seconds, ST is positive, VT is negative. You multiply them, you get a negative. So lastly, from 3 to infinity, ST is positive and VT is positive. So that means that the product ST times VT will be the product of two positive numbers for any t value in this interval, which will guarantee that the product will be positive. Now remember that we've said that if the product STVT ends up being positive, the object is moving away from the initial point. Remember, initial point, point of reference, or the origin mean the same thing. Now, when the product is negative for STVT, it means that the object is moving away towards the point of reference, and in the interval from 3 to infinity, and we are using the term infinity here loosely because obviously a cougar cannot move to infinity, right? Because we are living things, right? And the product will be positive, so which means that the object is moving away from the initial point or the origin or the point of reference. So we're going to say that away from the point of reference is in the time interval between 0, 1 and 3 to infinity seconds, and towards between 1 and 3 seconds. So you can imagine that the cougar is moving away from its prey initially, so wants to observe the behavior of its prey, and then within 2 seconds it gets closer to the prey in order to execute whatever the plan was, and then going away again. So next we'll take a look at analyzing when the object or the time intervals, or determining the time intervals when the cougar was speeding up or slowing down. So the process of analyzing speeding up or slowing down motions is very similar to moving away, moving towards. But this time, what we look into is the product acceleration and velocity. So we're going to start off by writing the velocity equation again, and I'm going to go over each and every step as if we didn't do the first part, only because, like in many problems, you may be asked one or the other. It doesn't really matter, but it's a better way of analyzing, I think. So we're going to start with finding the values of velocity, or the times when velocity is 0, so that we can study the sign of it. And I'm going to go over this fast enough because we just analyzed this. We know how it's done. So you make velocity 0, factor out 3, factor out the entire equation of velocity, determine the key values, which are at are found by making each factor equal to 0. So either t minus 3 or t minus 1 equals 0, which means that the key values for velocity are at t equals 3 and t equals 1. So now we have to determine the equation of acceleration. Remember, acceleration is the first derivative of velocity or the second derivative of position. So obviously it's faster here to differentiate velocity. And we're going to say acceleration equals Derivative of 3t squared is 6t, and derivative of negative 12t is negative 12. So we'll set acceleration to 0 in order to find its key values. And it turns out that there is only one key value for acceleration, and this is at t equals 2. So we're going to say that at time equals 2, acceleration will be 0. Now it's time to study the sign of Vt, of the product Vt At. And for this, again, we're going to use a chart similar to the one we used in the previous part of the question. So we'll start off with a number line, and we are going to build the rest of the chart by drawing a vertical line where we put here velocity, acceleration, the product, and then lastly, the description of the motion. So on the number line here, we are going to place the key values. So the key values that we obtained are, obviously, we're going to start at 0, and then numbers 1, 2, and 3. They need to be placed on the number line in order and not to scale. That's not necessary, even though in this case they kind of are very beautifully aligned because they are only 1 unit apart. So anyway, so we're going to start by placing these numbers on the number line. So 0, 1, 2, 3, and I'm going to leave infinity in here. Now let's start with velocity. So velocity has the factors t minus 3 and t minus 1. So the sign of velocity is dependent on the two factors, t minus 3, t minus 1, and obviously we have the number 3. We're going to list it here as harmless, but again, watch out for cases when the leading coefficient is negative because it can change the sign of the expression to opposite. So next, we are going to write the factors of the acceleration, which are, well, there is only one, basically 6t minus 12. So we'll say that the sign of the acceleration would be going down here. And lastly, we have to study the sign of the product Vt times At. And at the very bottom, we are going to describe the motion. So let's get to work. We're going to start off by studying the sign of each factor in each indicated interval. So you have 1, 2, 3, 4 intervals that we have to discuss. So we're going to say that t minus 3 will have the 0 at 3, and t minus 1 has the 0 at 1, whereas 6t minus 12 will have the 0 at 2. So best to start off with the zeros because they kind of remind us of where the function is changing the sign. So t minus 3 then will be negative for any value that is to the left of 3 because t minus 3 is an increasing linear function. So it starts negative, and once it hits the 0, it will become positive. So the values will be negative for any t less than 3 and positive for any t greater than 3. T minus 1. So this is the 0, t minus 1, which means that the leading coefficient is positive, right? So the line goes up, starts negative, ends positive. So we'll say it starts negative after the 0 changes to positive. So therefore, we'll say that the sign of Vt would be equal to the product of the signs in each interval. So therefore, we're going to have a positive. Here, a minus and a plus will give a negative, and then a positive. Now, let's do 6t minus 12. So we are studying the sign of 6t minus 12. So we have a minus for the same reasons as in these functions. It's linear, which means that it's a straight line with positive leading coefficient goes up. So starts negative, after the 0 turns positive. So starts negative, after the 0 turns positive. So now we can study the sign of At. Basically, there is nothing to study. We're just going to emphasize what the sign of At is. So now, in order to study the sign of the product VT-AT, we need to marry these signs together. So notice VT is all in green now and AT is all in orange. And if you multiply a plus with a minus, then we get a minus. Multiply a minus with a minus, we get a plus. Multiply a minus with a plus, we get another minus, and multiply two pluses, we get a plus. So remember that we said that if the product VT-AT is negative, the object is slowing down. If the product is positive, it's speeding up. So therefore, we're going to say that from in the time intervals from 0 to 1, the cougar is slowing down. So obviously the cougar is trying to be quiet, right? So that it won't be recognized by the prey. And between 1 and 2 seconds, that's positive. So that means that it is speeding up. So it's probably attacked the prey. And from plus to minus is slowing down. And from 3 to infinity is speeding up, is running away. So lastly, we were told to write or draw a graph or try to draw a sketch of the position, acceleration, and velocity for the first 4 seconds. So I will very quickly actually try to draw a description of the motion first. So remember that initially the cougar was moving away, towards, and then away again. So the way this works is that probably the cougar is going away from the prey. So if this is the prey, and then the cougar is going away from it, and then is going back, and then away again. So the motion will be following this pattern. And we can easily find the length or the position. This problem doesn't ask, and I don't want to make this problem a lot longer and more complicated, but we can also find the position between these time intervals to see how far the cougar has gone. But in general, this is how I would like you to picture the motion of the cougar. So, or the path that the cougar would follow, right? The actual scenery in a way. So as you can see, then the cougar would initially, in this path, will slow down, so get away from the prey, and then speed up, and then slow down in here because it's trying to, act upon the prey, and then execute the plan probably, and then speed up, so get away with it. So I hope that these explanations made sense. And if you have any questions, please let me know in the comments. Enjoy learning. Bye for now.